All right, this is Geometry B, Unit 5, Sample Work 5. We have a few words to define, so get out a pen or a pencil and write down these words, definitions, and sketched examples. The first word is chord. We're not talking about guitars or pianos. A chord is a segment connecting 2 points on a circle. So here's a circle, 2 points on the circle. A chord connects the 2 points on the circle. Chord. Number 2, circle. All points in a plane equidistant from one point. So here's the 1 point, all points equidistant from that 1 point. Number 3, diameter. A chord passing through the center of the circle. Okay, so a circle with a center and a line segment passing right through the middle, through the center. Four, radius. A segment connecting the center with a point on the circle. So here's a circle, here's the center, radius connects the center with a point on the circle. Okay, 5. Secant line. A line crossing a circle twice. So here's the circle. Secant line passes through the circle and intersects it twice. Secant line. Number 6. Tangent line. A line touching a circle only once. So here's the circle. Tangent line touches the circle just once. 1 point, not twice. Seven, arc. A piece of the outside of a circle. So here's the center of the circle. we have just a piece of it. That's an arc. Number 8. Central angle. An angle whose vertex is the center of the circle. Okay, so here's a circle, here's the center, so it's basically made up of 2 radii. Central angle. 9. Circumscribed angle. Okay. Circumscribed angle is an angle formed by forgive me for coughing here so much, 2 tangent segments. So here's the circle. One tangent segment. 2 2 tangent segments. Kind of looks like a duck. That would be the angle labeled X right there. Okay, number 10. Inscribed angle. An angle whose vertex is on a circle. That's on the edge. So here's our circle. Its vertex is on the circle. Inscribed angle. 11. Major arc. Okay, we already defined an arc. So a major arc is an arc between 180 degrees and 360 degrees. Okay, for this one I'm going to grab the circle drawing tool here. And I'm going to also scroll up here because we're running out of room. And we need some room, okay. So a circle. Okay, and the circle center. Let's do A here, and B here, and C here. Arc AB is a minor arc, Arc ACB is a major arc. So let's highlight the major arc in green, ACB, and the minor arc, which is the next word, in a different color here, in yellow. a minor arc. An arc between 0 and 180 degrees. In this case, arc AB. So arc AB is a minor arc because it's the short distance around the circle. The major arc is a long distance around the circle, and major arcs need 3 letters to name them. Minor arcs need 2 letters, though you can still define them with 3 letters. 13. Tangent line. Oh, we've already done tangent line, so skip it. 13. Semicircle. Is half a circle. Okay, so half of a circle looks something like this. It's a circle bounded by a diameter. The center is on the edge. 14. Incenter. The concurrence of the angle bisectors the center of the inscribed circle. So in a triangle, if we draw the angle bisectors, they all meet at a place called the incenter, and that is the center of the inscribed circle. That is a circle that just touches, if I can draw it, just touches all the sides. All the sides of the triangle are tangent to the circle. It's also the largest circle that can be drawn inside the triangle. Incenter. 15. Incircle. Also called the inscribed circle. It's a circle just touching all 3 sides of a triangle. Okay, and there's the example right there. I'll just highlight it. Incircle, or inscribed circle. Circumcircle, or yeah, the number 15. Incircle, inscribed circle. Yeah, we did that. 14, 15, incircle. 16. Circumcenter. The concurrence of the perpendicular bisectors. Also the center of the circumcircle. So here's a triangle we construct the perpendicular bisectors of all the sides, they all meet at the circumcircle, and that is the center of the circle that just touches all the vertices. 16. 17. Circumcircle. The smallest circle, or actually the circle containing all three vertices of a triangle. And I'll trace this again to highlight the circumcircle. 17. 18. Feel like the Alice in Wonderland tea party. Move down, more cups, clean cups. Gotta scroll up so we have more space to write. 18. Cyclic polygon. This word was new to me. What I call it is an inscribed polygon. A polygon whose vertices are all on a circle. So here's a circle. Okay, we put a few points, like these four, on the circle, and its vertices, its corners, are all on the circle. That's a cyclic polygon. Got to scroll down. My list has reached the end of what I can see. Constant of proportionality. Okay. The ratio of new to old. New to old. So constant of proportionality for degrees to radians is 360 to 2 pi. Actually, that's going to be radians to degrees. Radians to degrees, yeah. So new to old. New goes on top. So what am I converting to? I'm converting 2 radians. So 2 pi to degrees 360. Or in this case, reduce pi over 180. That's a constant of proportionality for radians to degrees. Or degrees to radians. No, yeah, degrees to radians. Vice versa if you're going the other direction. I just have to think a little bit about the direction I'm going in that one. Helps to think big to small, small to big. What do you need? 21. Constant of proportionality, radian. The angle subtended, and I'll explain what that means, by 1 radius. Okay. So imagine, if you will, a circular arc whose arc length is 1 radius. 1 radius. There we go. Okay, so 1 radius. In other words, where that arc length, that curved path, is the same as the radius of the circle. That is 1 radian. Okay. 22. Sector. Yeah, we haven't defined that yet. It's a piece of a circle between 2 radii. And since this is the last one, I'm going to draw it down below. Draw my circle of radius 3 here. We'll make it a close to a quarter circle here. That's a sector. There's 2 radii, and the piece of the circle that's bound between them is a sector. And we can find the arc length of the sector, and we can find the area of the sector. Okay, somewhere I missed. Oh, I skipped 19. There it is. Okay, so let me go over here. Probably screaming at the computer going, what happened to 19? I knew there was one I missed. So let's move that up here. Don't you wish you could do that on paper? And 23 I'll call it, since I skipped 19. I'll call it 19. Just to keep, so the numbers work out here. 19, which belongs up here, okay, is inscribed quadrilateral theorem. Okay, an inscribed quadrilateral is an inscribed polygon. So in an inscribed quadrilateral, comma, opposite angles are supplementary. That means it adds to 180 degrees. So let me give you an example. So we've got a circle, 4 points on the circle. 1, 2, 3, 4. Anywhere on the circle. They don't have to be evenly spaced or anything. So we've got a quadrilateral. That means 4-sided polygon. Connecting each of these 4 points. And opposite angles add to 180 degrees. So if this is 115 degrees, then this angle must be 180 minus 115, which is 65 degrees. And if this angle is 44 degrees, then this angle must be 180 minus 44, which is 136 degrees. Opposite angles, add to 180. All right, that's it. Whew, that was quite a list.